Okay, for the second problem, we're going to consider a curve as an equation, xy squared minus x to the third y is equal to 6. We're supposed to find dy dx, find all the points on the curve that are tangent, that are horizontal, explain your reasoning, all the tangent lines that are vertical, explain your reasoning. Okay, so the first thing we need to do is look at that curve and figure out how to take the derivative. So we have x y squared minus x to the third y is equal to 6. And I'm going to switch colors with every step here so that you can see what we're doing. So the first thing we're going to do, we need to take the derivative with respect to x of this entire thing. So since we have xy squared, that requires us to use the product rule. So the derivative of x is just 1 times y squared plus x times the derivative of y with respect to x, which is 2y dy dx. So that's the first term, minus 3x squared y minus x to the third dy dx. And then the derivative of 6 with respect to x is just going to be 0. Okay, now I'm going to group like terms. I'm going to take x squared y dy dx minus x to the third dy dx, leave it on one side, and then I'm going to take y squared and minus 3x squared y, move it over to the other side. So now I'm going to have 2y dy dx minus x to the third dy dx is going to equal 3x squared y minus y squared. Okay, next step is to group all of our like terms over here. We're going to have 2y minus x to the third dy dx is equal to 3x squared y minus y squared. Divide both sides by the term in front of dy dx, and we get our answer for the first part. Dy dx is equal to 3x squared y minus y squared over 2y minus x to the third. Okay, so that is our first step. And part 2, or part B of that question says, find all points on the curve where the tangent line is horizontal and explain your reasoning. Well, the tangent line is horizontal where, so for part B, tangent line is horizontal, just use those marks for horizontal, when dy dx is equal to 0. Well, dy dx is equal to 0 when the numerator, 3x squared y minus y squared, is equal to 0, right? So let's do some type 1 factoring. Y, 3x squared minus y, is equal to 0. So either y can equal 0 or 3x squared minus y can equal 0. If you go back to the original equation, can y ever equal 0? Going back up to the original, if y were equal to 0, you'd get 0 equals 6. So y cannot equal 0. So what that means for us in part B is 3x squared minus y is equal to 0 will be the point where you'll have a horizontal line. And it might be 1 point, it might be 2, we don't know yet. So what you really get is when y is equal to 3x squared, every time y is equal to 3x squared in the original equation, you will have a horizontal tangent line. So if we go back to the original equation, substitute in 3x squared for y, you would get x, 3x squared squared, minus x to the third, 3x squared, is equal to 6. So that's 9x to the fifth minus 3x to the fifth is equal to 6. 6x to the fifth is equal to 6. X has to equal 1. X can't be negative 1 because the exponent is odd. So when x is 1, you have a tangent line at the horizontal. So if x is 1, what is y going to be? Well, let's go back over here. And when x is 1, y is going to equal 3. That's a 3, folks. So it's at the point 1, 3. Okay, so that is the answer to part B. So for part C, what makes a tangent line that is vertical? Well, the vertical tangent line would be when dx dy is equal to 0, which would mean when, oh boy, I messed something up here. Let me go back. There should be 2xy. Should be an x there, there should be an x there. And that's where I dropped my x. Okay, so dx dy is when the numerator, which would be 2xy minus x to the third is equal to 0. We'll factor out an x. 2y minus x squared is equal to 0. So x is equal to 0, or 2y minus x squared is equal to 0. So can x equal 0 going back to your original equation? No, then you would have 0 equals 6. So you have to have 2y is equal to x squared, or y is equal to x squared over 2. So we go back, we do the same thing. We put x squared over 2 into the original equation. We get x squared over 2 squared minus x to the third, x squared over 2 is equal to 6. This becomes x to the fifth over 4 minus x to the fifth over 2 is equal to 6. Our common denominator is going to be 4. So x to the fifth minus 2x to the fifth is going to equal 24. All I did was I got a common denominator of 4. So the first term is x to the fifth over 4 minus 2x to the fifth over 4 is equal to 24 over 4, and then just got rid of the denominator. So you get negative x to the fifth is equal to 24, or x is equal to negative fifth root of 24. So applying that value for x and going back and doing the same thing as we did in part B to get the y, you would get the points would be negative fifth root of the square root of 24. And then the y is just x squared divided by 2. So it's negative fifth root of 24 squared divided by 2. And those are your answers for that. Let me go through quickly and score the points for you. And let me get the red marker. So this problem is worth 9 points. The first one, if you come up with this correct solution for dy dx, that's worth 3 points. And you lose 1 point for every error that you make. Part B is worth 3 points. Here's 1 point, setting the numerator equal to 0. Here's another point, properly dealing with y equals 0. And then the other point for that, so the 3 points are setting the numerator equal to 0, realizing y equals 0 cannot be a solution, and then coming up with a point. And then part 3, set the numerator equal to 0, properly deal with x, and then come up with this as your point again. So those are all of the things you needed to do to score 9 points on this problem.